Okay. Let's see. I don't know if anybody else. Oh, come on. Nope, because of these guys. Yeah. I don't know if anybody else is going to show up today. Our attendance has been slowly dwindling down to just you three. So we'll see. But, you guys want to go over anything in particular? If anything, questions? How are you guys doing with, like, just the homework and everything? Are you guys okay? Like, no particular difficulties or anything? Okay, good. I mean, that's what I like to hear, for sure. All right, let's see if that stays on now. Okay, so last time we were going over indirect proofs and conditional proofs. You feel good about that? Kind of, a little bit. Let's do, did we have any problems left over from last time that we were still going to do? Okay, yeah, I don't think so either. I don't remember at least. So let's do a couple practice problems today, but did any of you bring one of the arguments, like an example of an argument that you made? No?
I did one. I don't think it's good though. It's just like hypothetical syllogisms.
Yeah. Can you come up and put it on the
Okay.
board? Yeah, let's just look at it real quick.
Do you want me to like write it in English or just symbolize and explain?
Yeah, you could just, whatever you want to do. I mean, depends on how much time you want to put into it. But symbolizing and explaining is totally fine.
Okay.
You know what I might have you do? Put a little, I'm going to show you all how to make a key. Draw like a rectangular box here, like big enough for you to write your sentences in. Yeah. And then what you'll do is you'll put H equals, and then a sentence, right? And you'll do that for each one.
Okay. So like that.
Cool. Okay, nice. Yeah, so that's how you make a key. When you're giving a logical argument and you give in symbolic form, you can either do what I'd like to do, which is, fill your paper, 2 pages of your paper with the argument and then the symbolic, and then a couple paragraphs explaining what you're talking about. Or you can do this. You can give your argument in symbolic form and then give a key to interpret it. Right? So that's perfect. Okay, so now explain to us what this argument does.
Okay, so my dad likes aliens, so I did one to prove that aliens are real. Basically that like if there's something that humans didn't do and we don't fully understand, it's evidence for aliens. And that if there's an orb and it travels faster than light, then humans didn't do it and we don't fully understand. And then like once you get A, like there's evidence, like then aliens are real.
Okay, cool. Okay, yeah, so one says if there's something not done by humans and we don't understand it, then that's evidence for aliens. If there's evidence for aliens and aliens are real, it's 4. And then 2 and 3 are just establishing that there are evidence for aliens, right? So yeah, do the proof on it real quick.
I like added 3 because if I didn't have it, I would have to do like a conditional proof, I guess, and I wasn't sure like if I could do that. I don't know. But basically, I like got A through like a lot of hypothetical syllabus, so it's like going from there to there, and then A to R, so then you get R from those times.
Okay, yeah, that makes sense. Cool. Yeah, so you'll just do a series of hypothetical syllogisms and the modus ponens, and then you'll eventually do it again and again until you get to R, right? Make sure it's valid. So that gets you that. Yep. Okay, cool. Good. And I don't have any particular criticisms of this one. I mean, this one is...
I made it simple.
Yeah. No, it's good. Yeah, this is exactly what you'd want in a real argument. I guess the only nitpicky thing there would just be, but there is a way to save it just by rephrasing some of the things, is that each of these has to stand for a full proposition, and right here, a lot of these as written are properties.
Oh, okay, yeah. I like
Does that make
just
sense?
wrote the whole thing out. I just
Yeah.
yeah.
And like I was saying, that's totally fine. But it is interesting to note, this is how we more naturally think in terms of properties and subjects, and we're right on the cusp of learning how to do that. But yeah, this is great. I mean, this is solid. It's a good, solid argument. I mean, this is clearly false, right? Like, yeah.
My dad would like it though.
Right. It's great, yeah, good. I think that's our first one that has not had sort of the major obvious flaws of like inconsistency or redundancy or something like that, right? So it's good. Yeah, the only problem with it would just be 4 if you have evidence for something that doesn't necessarily mean it's real, but yeah, good. Any questions? Anybody else have an argument they want to share? Come on up. There you are.
So before I do this, I just want to say, I don't believe this, but it's the first argument that came to my mind. So this is going to be an argument kind of against the traditional conception of God. So kind of the opposite of argument last time that Jesus is the Son of God.
Yeah.
So one is okay. So if God is kind of a classic omnipotent, omniscient, and omni-good argument.
My professors always call that the triple OC God. Omnipotent, omnipresent, omnibenevolent, and a creator, yeah.
Mm-hmm. Okay, so
It'd be fine either way, just for the record. Good, nice. Okay, so explain it real quick to us.
Okay, so if God is omnipotent, he can prevent evil from occurring, which seems pretty self-explanatory. If you're able to do everything, then you should be able to make evil not happen. If God is all good, he would want to prevent evil from occurring. That also seems to make sense, right? If God is all good, then he would want all good things to happen, and he wouldn't want evil to happen. And 3 is, if God is omniscient, he would know if evil is occurring. So basically, if you know everything, then you know that any one thing is occurring, and so you would know that evil is occurring. And so 4 is that if evil exists, then God is either unwilling to prevent evil, unable to prevent evil, or doesn't know that evil is occurring. And so based off of those 3 kind of previous ones, that would make sense, right? And number 5 is evil exists. I don't think that's super self-evident, but I think most people would agree that evil exists. And so then the conclusion is that God is either not omnipotent, not all good, or not omniscient.
Nice, okay, cool. Raise your hand if you think it's valid. You got 1 for valid, 2 for valid. 3? Okay, yeah, I think it's valid too. Let's put in the symbols and prove it. One thing interesting to note will be that, and this is not a criticism, so don't take this as a criticism. 2 says if God is all good, he would want, right? But 4 says God is unwilling. Now, those words aren't the same thing, right? But you are expressing the same ideas there. So the point that I just want to make here is when you're giving an argument, you will almost always see different words used to describe the same thing. And that shouldn't necessarily be symbolized differently. You've got to look at the conceptual content, not just the words expressing it. Does that make sense? So when I want to do something, that means that if I get the opportunity to do it, I'm going to do it. The old-fashioned way of talking about what you want is what you will to be done, right? I will something to be done when, if I was given the opportunity, I would make it happen. We say want now instead of will, right? So those are the same things. So I just wanted to clarify that. Your terminology in written English does not have to be perfect, right? The point of logic is to make it, to show you how it's actually, there's no actual equivocation or change in meaning going on there. Okay, so yeah, let's put it into symbols.
Okay. I put up the whole board.
It's okay.
Does everybody kind of get this?
If you want, you could put the symbols next to each of the written premises, just on the right-hand side.
Oh, that would make sense.
Yeah.
Great. Okay, so basically, so O is going to be omnipotent, then he can prevent evil from occurring. So that's going to be can. Let's see. So God is all good. So that's going to be symbolizes A, and he would want to prevent evil from occurring. So that's going to be W for want. God is omniscient. I'm going to do K for know, like all-knowing. And then he would know if evil is occurring. Actually, I'm not going to do K because I want K to be this one. So what should we do? I'll do S for omniscient.
Yeah, I was thinking the same thing.
Yeah. And so then, if evil exists, we're going to do that as E. Then we're going to have unwilling to prevent evil, so that's going to be not W. Or unable to prevent, so that's going to be not C. Or doesn't know that evil is occurring, so that's going to be not K. And so number 5 is just that evil exists.
Good. Nice, cool. All right, now for the proof. Let's do it.
Okay. So 6. Yeah. We can get. Okay. With 4 or 5 notice opponents.
Good.
And so I did something kind of weird. And can you do like a constructive dilemma with 3 different things?
Ooh, yeah, technically you can.
Okay.
Yeah, I mean, that works. It's just like a big ass constructive dilemma.
Yeah, because that's how I did it, but in the book you didn't do it like that, but I was thinking the logic should be sound.
Yeah, no, absolutely that logic is sound. Yeah, I see exactly what you're getting at.
So, what I did is I rewrote each one of these as they're kind of in their transposition. Right, so I had not C implies not O, but not W implies not A, and not K implies not S. So that's just 1, 2, 3 transposition. And so then I did And so then with 6 and 10, or this is just 7, 8 conjunction. And so then if you use a constructive dilemma here and here, then you should be able to get the conclusion. Or not. Yes. And then you can just 6. You can reorder those using commutativity.
Good. Nice. That's great. That's, yeah, interesting way of doing that proof, right? A big 3-part Trinitarian constructive dilemma you just did there, right? That's great. I like to see that because, yeah, that's not in the rules. Technically, the rules as written in the book wouldn't let you do this, but you can see that if you join all these together and reverse them with transposition and then do, or is it transposition? Yeah, transposition. And then just do a constructive dilemma on all of the antecedents, then it works out, just like a constructive dilemma normally would. What is the other way of solving this without doing that? Well, let's say we start from 7, because it'd be the same as 6. What would the other way of solving this be? Yeah, we could most Tolan's everything. The problem though is we don't have anything by itself to negate something here, right?
No, I meant get E first once you have E's.
Oh, so you get E and then you get this, right?
Yeah, and use those to modus tollens premises 1 through 3.
Right. The problem is these are connected with ors instead of ands. So we'd have to have them connected by ands and then simplify them to do a modus tollens or tollens here. Does that make sense?
Oh yeah, I didn't see that movie.
Yeah. So that's kind of the tricky part. That's why this constructive dilemma is clearly a good way to approach this. I'm trying to think of the other way to solve this. I think
Could you use De Morgan's to eventually flip them to N?
you could. So if I did a De Morgan's on, let's take 6 for granted. So I'm starting at 7. So if we take 6 for granted, sorry if I'm writing a beautiful argument.
I guess you couldn't, because then that would make them positive.
So 7 I wanted De Morgan 6, which would end up being what if I De Morgan 6? So 6 is not W or not C, right?
So
Or
it'd be
not
WNC.
K.
Just kind of ruins that part.
It'd be what?
Maybe WNC, which kind of ruins that part.
Mm-hmm. So it'd be not W and C or not K. What if I want De Morgan's this whole thing? This whole thing.
Would it be, not, and then parentheses, W and C, or K?
It'll still be and
Oh,
K, yeah. So and K. Good. So there's a De Morgan's there, 7 De Morgan's. That doesn't really get us anywhere though, right? I mean, it does. It's just hard to see exactly where this gets us. Any other ideas? Let's see if this works. I don't know if this is going to work. But let's see. If I take O then C, and I use material implication on it, it'll give me not O or C, right? On 1, material implication, I can't remember how the book, so that's 1 mile, I guess, whatever. I'll do the same for 2 and 3, not A or W, not S or K. 2, 3, oh, it's implication, isn't it? Yeah. 10, so now I've got all of these. Then I do, oh wait, let me see. W or not C or not K. Then maybe I do this with material implications of backwards on these. So it would get me W then not C. W then not C or not K. Right? Material implication on 6, does that make sense? And then I do the whole thing, which I could have done off the bat, I guess. And then that does if W then not C, then, or if not W then not C, then K, not K. Which would be with transposition K then W then not C. Which, if I then kept doing this for the next 15 minutes with all of the different parts, I'd be able to do a series of hypothetical syllogisms. And then I would eventually get something like S then K, or I'm sorry, S then W then not C, right? 14. From 12, 3 hypothetical syllogism, and then I could do, now I turn it back and I go S, then not W or not C, and then 15, and then somehow I'll be able to do a modus tollens in there eventually, by transforming something in this big cluster and then negating these one by one. But that would take a lot of time, so I'm not going to. Does that make sense? Kind of. You'd have to work it out. And I'm not going to spend the whole class working that out. But yeah, so this, making up the constructive dilemma, a 3-part constructive dilemma, is the most straightforward, simple way to do it. But sometimes to do, a real argument and to do it justice and to prove it simply will require, kind of not just relying purely on the book. The book is very limited. Okay, any questions or anything? Anybody else want to share an argument? Okay, so let's do some practice with indirect proof and conditional proof. Get my book open here real quick. Okay, so we're going to do 7.6.1. Did I already assign some of these in class? Remember? I don't think so. So 7.6.1, and let's do, all right, ready to remember your numbers? 10, 11, 12, 13. 7.6.1. I'm hoping it's the same in the 13th edition. These should just be straight proofs with conditional and indirect. So if they're not, let me know. All right, let's give that a minute, and then we shall put it on the board.
Mine has like a typo or something for number 13. And it's one of the ones that has the answer given, so you only do it on.
Yeah, you want to just do 14 then? I know 14's gonna be tricky. I'll give you with 14, and I believe also with 10, you'll have to make a lot of assumptions to get there. Who's done? Okay. Still working?
I'm done, I'm just rewriting it because my handwriting's bad.
Okay, cool. Who wants to go first? Come on up. Okay, cool.
I remember how to do this correctly. I started by assuming not that, right?
Sure, yeah.
Yeah.
And you can assume technically whatever you want. So you're gonna take the indirect proof approach? Okay,
Yeah.
cool. Good. Now, anything you get with an indirect proof, you can get with a conditional proof. They're the exact same technique logically. They just have different starting points. You might have to make a shit ton of assumptions with a conditional proof to get the same result. And that's why the indirect proof's nice, because sometimes it can cut through that.
Let's see, it will be
Good.
get not C and not E. I'm
Good.
just separating it. You can get the negation of each of these. Those columns. Okay, and you can get not A and not B if the one ends in a seven.
Good.
A and not D if the one ends in eight. Double negation, you want me to do it, you get not A from nine, the simplification. A from 10 simplification.
Good.
And then you get A and not A, conjunction. And that's a contradiction, so.
Beautiful. Nice, that's great. Yeah, perfect. Great. Any questions on this one? From anyone? No? Okay, good. Yeah, that's great. I like that we're getting into these longer proofs, and we've been able to do them so far pretty easily. All right, who wants to go next? Who's next? I need a volunteer. Come on up, sir.
So I have a few different theories.
Yeah, this one's fun. I just did 10 and 14 just to make sure I knew how to do
I
it.
was working on the theory too, so before I potentially waste everyone's time, the first one, if I could just assume F then G not G, is this correct to be, and then assume again G, then G then H, assume all of it, and assume again not G?
Let's put it on the board and see how it works out step by step. Because yeah, you can get the same result with a series of conditional proofs,
It felt cheap to just assume everything.
but it's fine because it's just an assumption, right?
Well, I mean, yeah, I feel like I can't do that.
Okay. So let's see how you can get this with trying to do a conditional proof. Let's see if it works out. Because we're just starting from F, right? That's not much to work with to get that big conclusion.
So assuming that you have F and that gives you G or not G. We only have F, so and now I go like that.
Yeah, you just gotta assume for conditional proof ACP.
And then would I assume again that G is correct? Like, can I do that?
Yeah, you can do a conditional within a conditional
Like
assumption.
like a pathway almost?
Yeah.
Okay. G is correct. And then would I write ACP again?
Are you gonna assume another thing?
Yeah.
So you're gonna do 3 within it?
So would I assume again with the indent?
Yeah, that would be an assumption again there. So yeah, you'd indent that again and then do another conditional proof assumption.
Assume H.
Yeah.
Sure. And then, so if I'm assuming not G, I would line it up with this one, right? So path 2 is not G, so I go not G.
Oh wait, so is that another assumption?
Yes.
So that would be another one within, even further indented from
So it's
the
not
last one.
within that one. It's on par with this one.
Yeah, so, but right now, so think of it as like nesting dolls. Like every time you make an assumption, it's an assumption within an assumption within an assumption. Until you close that assumption, then it returns you one level up. Does that make sense?
I guess I intend to close that assumption then. And
Okay.
say that if you have G, then it gives you H.
If you have a G then. Well, okay, so but the problem is, if I assume, let's just say I assume G then H,
Mm-hmm.
and I immediately close it,
Yeah.
my result isn't going to be G then H. It's going to be if I assume G then H, then G then H is true. Does that make sense? So if this is my assumption, and I immediately close it, then that's all I get. Which is just to say, if my assumption's true, then my assumption is true.
Yeah.
Does that make sense?
Circular. I just don't really know how to exactly do
Yeah. No, this is hard. And taking the conditional proof route
And then-
is difficult.
it. My second theory on how to do it was to use implications. Assume not G or H.
Try that one, see where it leads, if you have to erase a little bit. So you could just, if you want to do implications, you just erase 4, 5, and 6, right? Is that what you're thinking?
No, because I was just going to assume not G right off the bat.
Oh, okay. Yeah, let's try that. See, it's fun.
Okay, so assume not G. So then I could just go G, H. So grammatically, I guess is the right word to use. How would I do 2 parts?
Yeah, that's the tricky thing. I was trying to do this proof a few minutes ago the exact same way you're doing it, and I got stuck. There is a way to do it, but I couldn't figure it out.
There's an extremely cheap way that I see, and that is simply just to say, use addition and get that.
Okay, try that and see what
Well, no,
happens.
because that would work, because then I could say G or H or, and then just not G or J.
Yeah. So try adding that.
That just gives me the conclusion.
Right. So now if you close out your assumption, what do you get?
So, oh man, because isn't it not G then?
Mm-hmm.
Okay.
Yep. You end up getting not G then H or not G then J.
How do you do this one then? 'Cause
I mean, you could keep going and try to figure out the conditional proof. I mean, I think it's fun, and I'm going to be thinking about this when I'm trying to do it in my head all day. But the easier way to do it will be with an indirect proof.
that's the one where you just say not right?
Yeah, you basically just negate the entire conclusion, and then see if you can entail derive a contradiction from that. And if you can derive the contradiction, then you know that the conclusion has to be true, right? Does that make sense?
Yeah.
So we negate that conclusion for an indirect proof.
So I'd say not QH or not.
No, so you just bracket that entire thing and say not the entire conclusion.
Sorry, it's taking so long.
No, you're good. This one's challenging.
Um,
That would just be AIP, assume for indirect proof. Good.
I could go to Morgan's,
Mhm.
right? And then get not that and not that.
Yeah, that's what I would do.
And then, would I split them up?
You don't have to, you could. You can either split them up and then do something with them and then join them back together, or you can just do things to both sides while they're in the conjunction.
That's the thing, I don't know really what to do with them just because I have nothing to go off of.
Right. So, okay. With 3, I want you to do you remember the implication rule?
Uh-huh.
Do an implication on both the conditionals in 3.
Keeping the parentheses.
Keeping the parentheses and keeping the negations outside the parentheses too.
So be not G or H, right?
Yes, good. Exactly. Good. Okay. So that's an implication from 3, and then now that you've got that, you can do De Morgan's on them.
Okay. Hold up. So I go and with the, so it'd be G and not H.
Yes, beautiful.
Oh, would I do am I doing De Morgan's on the whole thing? So this would be-
Just do De Morgan's on each part.
Oh.
Yeah, so you're right.
And then that'd
Good. Now, what's that say on 5?
there's a contradiction of G and not G.
Right, and it's saying all those are true, so it's a true contradiction there, right? So now just simplify out what you need to show the contradiction.
Like that?
Yeah, there you go. And then you can either conjoin them together for G and not G if you want, or you can just leave it there. It doesn't matter. And then you close out your indirect proof.
So I forget, I would just start writing over here basically.
Yeah, you just start right over there. You close that out and you just say, well, from 1 through 8 IP, that marker sucks. 1 through 8 IP. We know the conclusion is true, so you just state the entire conclusion.
That,
Yeah. because if we assume the conclusion's false, then we get a contradiction. Well, contradictions can never be true. Anything that entails a contradiction can never be true. So the conclusion, because the denial of the conclusion, the conclusion being false entails a contradiction, then the conclusion must be true, right? There you go. Now you could have done that with conditional proof. I don't know how. I did the same things you did and got stuck.
Yeah, I had no idea.
But there's some way we could have done it. I'm just not good enough to say it. But yeah, there we go. Good. Yeah, 14 was hard. All right, who's next? All right, well, there's only two, so eeny, meeny, miny, mo, catch a tiger. Oh, here we go. See, I didn't even have to do it.
You know how in chemistry the balancing the equations, like, for some reason kind of feels like a game, it's
Uh-huh.
like a puzzle.
Yeah.
It's not, it doesn't really feel like work, it feels just like a puzzle.
Mm-hmm.
That's kind of what the proofs feel like. They
Yeah.
feel like puzzles, like games.
Yeah, that's how I feel about the proofs, although I failed chemistry in high school
Yeah, I
and
understand.
hated it in college, so I was just not good at those puzzles. Although I bet I'm going to start reading an intro to chemistry textbook because I'd like to understand chemistry and physics better.
Just some light Thursday evening reading.
Yeah. I started reading there's this one free textbook online called Atoms First, and it's like an introduction to chemistry, but it starts you from the ground up of literally like, this is the building blocks of everything that exists. And then here's how atoms work and were discovered. And then like 100 pages later, they're like, now we can learn chemistry. And I'm like, that's cool. But it's very boring. So I have not read very much of it.
One of my friends named Jaden Dixon, he's in a chemistry class, I forget which one. The homework is only like 6 problems long, but this thing, it takes 2 to 3 hours to do a problem. Like their review session for his midterm was 7 hours.
Oh my God. That's horrible.
I would cry.
Yeah.
And it was on Zoom, so he had to stay there.
Yeah, that's really, oh God. All right, so let's take a look at what you did. So again, another tricky one just because we only have K to work with and we're supposed to prove that. How do you do it? What'd you do?
I just assumed the S to like start it, and then added the T.
Good. So
At
you,
first I had a T, and I was like, I don't know how to do this.
Yeah. No, I mean, it's tough. I mean, I guess you could have done it, right? So you went S, just your assumption, you added not T. Now, then you did your implication on that, which not S and not T, then you transposed it, T then S. And then 6, I mean, just look, if I assumed S, then what would follow is T then S, right? So just by assuming S, you're able to get this. Why? How does this work? Like how, like this feels cheap, right? Like how just from this, you're not even using this. How can you just show that, well, this is, basically what you're saying is this is always true. You know, it's just true in virtue of, if you had S, then you'd have T then S. How does that work?
It's quite convenient.
Yeah, it is quite convenient. I don't know exactly how to explain how this works, but since we can trust our rules and trust our procedures, it must work in some way. So if I was going to do a truth table on this, actually I guess I'd just say S, T, true, true, false, false, true, false, true, false. Move over here. I'll just copy everything down so we can see it. true and true is true, false and true is true, true and false is false, false and false is true, true then true, true, true then true, true, false then false, true, false then true, true. So what's that make this statement? A tautology, yeah. So this is always true. This is a matter of logic. It's just always going to be the case that if it's true then S, then T then S. Can I exactly explain that? Not really. If I gave you an example, if I go to the store, then if I woke up today, then I went to the store, that doesn't really make sense to me. That doesn't shed any light on it. But if you put it in a truth table, you can see that it's always true. Right? You can check it. So if a tautology is always true, in some logic books, you can just assert any tautology you want without being a conditional proof. You can just go basically, and I think this is right, you should be able to do this. If I'm doing some proof, I should just be able to go for, I assert P and P, right? Like P and P. I don't have to have, oh, I'm sorry, P, or I could say P or not P. Even if I don't have P somewhere up here, I should just be able to assert a tautology, right? I guess it'd be P or not P. Or if I need to assert something like if P, then P. I don't know. So what the conditional proof does is it essentially is just a way of showing you step by step how this is true, right? Well, because if I had S, then I could add a not T to it, and then I get this and this, and I would finally end up with this, which means that, right? Is it useful in everyday argumentation? Probably not. But technically, it's logically valid. Any questions? Okay. This type of stuff is why logic is very mysterious. You ready for the last one? Logic is very mysterious because it's like, okay, wait, this doesn't really have application in everyday life. Something like that probably does not have application to early human survival in our evolutionary history. So where did that ability come from? Where did this logical ability come from to have these weird, complicated, almost cheap or bullshit sounding things, but then you check them against really concrete reasoning and you find, well, wait, that works. Where does it come from? I don't know. I guess the two theories would be that the evolutionary process has some of the things necessary for our survival involve the evolution of certain reasoning faculties. And then those reasoning faculties, just as a spin-off consequence, were so complicated that we can now do this stuff with them. But this stuff did not have any direct survival benefit. But then the question is, if these are mere results of the evolutionary process, then why do we trust them to give us reality, right? Interesting. Okay, so we've got K, secondary proof.
Yeah, so our conclusion needs to be not K, and the negation of that is not K, is K. And so then we can just do addition to get K or L, and then using a bonus function for 4 and 1, we can get N and N. Then we can get N, just using simplification on 5, which allows us to get N or O, just using addition. And we're doing that so that we can do that one. 6. Addition. can't happen because those are opposites, so then we must conclude, okay,
Good.
we got 3%.
Nice, beautiful. Very good. All right. Any questions on this one? We good? Okay, we can call it there. Are there any questions in general or anything we want to go over? Okay, so obviously the next test has already unlocked. I don't think it's due yet, right? Does anybody know when it's due?
It's due Thursday.
Due Thursday? So get that test done. Again, it's going to be just like the last one. It'll be fairly simple. It'll be mostly proofs, but it'll be using all 18 rules. I won't test you on indirect or conditional proof. I'm satisfied to see that we are able to use it and kind of get it. So that's enough for me. I think Thursday I'll start a little bit early introducing some of the new material, so make sure you come to class Thursday. Because the stuff we're about to get into takes on a whole new level of complexity. And we end up getting 4 more rules on top of our 18. And yeah, when I tell you that this next level of logic, predicate logic, is more complicated, I mean, literally, you will have, oh man, at least 3 times more symbols to represent a single proposition than we have now, right? Because a single proposition now is just P. But when you break things into subject and predicate, one proposition can end up looking like this, right? Something crazy like that. Or even worse, it could end up looking like, one proposition. Does anybody know what this says? Is anybody ahead and could translate this?
That for all x there exists a y such that for all z p x y z.
Yeah, so it's a relational predicate. X stands in relationship P to Y and Z, a 3-place predicate. So these have a relationship between them called P. And then we're saying here, for anything that exists X, it's going to have this there is a Y such that for any Z they have this relationship. That would normally be represented as one proposition, right? So come to class Thursday because we're going to enter the whole new realm of hell. Okay, I will see you all later. Questions, comments, anything? We're good? All right, I will see you next time. Take it easy.